Hello, my name is Jackie Russell. I'm a graduate student in mathematics at Loyola University of Chicago. This is another video in my series of videos on various mathematic topics. So today, as you can see, we're going to be estimating areas under a curve using Riemann sums. So let's get started. So the problem statement that we're going to look at today is we're going to estimate the area under this curve, f of x equals x squared plus 2. And we're going to do that from -1 to 2. Now, without thinking about the math too much, if you think about just having some random object that is a weird shape, and you want to know what the area of that object is, say it's a t-shirt or something like that, where it's not easily determined what the area is. If you can break that object up into smaller parts that you can take the area of, say a rectangle, then you could add up a bunch of small little rectangles that comprise the overall object that you started with, and you can get an estimate of the area of the object. So that is what we're going to be doing here as well. So if you think about this, we're trying to estimate this area from -1 to 2. So all of this area here between the x-axis and the graph, we're trying to find out what the area there is. So what's a relatively easy way to estimate that? Well, we can divide that area into some little rectangles, and we can try to figure out what an estimate of the area is by adding up our little rectangles that we create. So we need some method to determine what the width and height of our rectangles are going to be. So this formula here is going to give us a formula for the delta x, or the width of each of the rectangles that we're going to use. So let's start with an easy example. We're going to separate it into 3 intervals. So if we separate it into 3 intervals, then our formula here tells us that the width of our rectangle, or our delta x, is going to be b minus a. Now, so if we look at our values here, our a value is -1, our b value is 2, our n value is the number of rectangles we chose, which we said was going to be 3 for our first example. So let's plug those in here to our equation, and we're going to have a b equals 2, and then a is -1, and that's all over our n, which is 3. So this equals 2 plus 1 over 3, and that's just 1. So that's 3 over 3, or 1. So our delta x is going to be 1. So in other words, the width of each of our rectangles is going to be 1. And you can sort of easily see that. We have 3, from -1 to 2 is a 3-step interval, and then we're going to divide it into 3 equal parts. So we're dividing 3 things into 3 equal parts. So that then we would divide it into parts of 1. But you can use this formula to determine that as well. So we're going to look at then, so we know what our width is going to be. Now, how are we going to determine what the height of each of the rectangles is going to be? Well, we're going to pick a point somewhere on this graph to make the height of each of our rectangles. So we're going to use left Riemann sums. So that means we're going to pick the value of the graph at the left point of our rectangle. So in other words, this first rectangle, the width is going to go from 1 to 0, right? That's the width of the rectangle. Then the height is going to be from this point down, and then we'll bring this over here, bring this down here. So this guy here is our first rectangle. Now we know the width here is a 1, because that's our delta x. Well, what's our height? Well, the value of this function at -1, we just plug -1 into the function. -1 squared is 1, 1 plus 2 is 3, so then that makes this height 3. Okay? Now we're going to do a similar thing here. Our width is 1, so we're going to go from 0 to 1. That's our width there. Now our height on this instance, we're going to start at this value. This is where the graph is, so we're going to go from here, then we're going to go over and down. So this guy is our second rectangle. And again, the width here is 1. Well, and our height is, what is the value at 0? The value at 0, the function is just, the function evaluated at 0 is just 0 plus 2, or 2. So then the height here is 2. Let me see where I can. So the height here is 2. All right. Now we've got to make one more rectangle. So we'll make another rectangle here. Let's make this one pink. So again, our width of our rectangle is 1. We're going to choose this value here as our height. So we'll drag that down there, move that across, down. So this guy is our third rectangle. And again, our width here is 1. And our height is, well, what is the function evaluated at 1? 1 squared is 1. 1 plus 2 is 3. So this is 3. Now, what we need to do is just add all of these up. And we have some very easy numbers here. So the area of this rectangle is just 3 times 1, or 3, plus the area of this rectangle is 2 times 1, or 2, plus, and the area of this rectangle is 3 times 1, or 3. So add all those up and we get 8. So that is our estimate using 3 rectangles of this area. Now you can look at this visually and see this rectangle here is an overestimate of the area, because our rectangle actually has a piece of it here that's actually over the graph, because we really just want this shaded area here, right? The area under the graph, whereas this rectangle is actually giving us this extra area here, which is an overestimate, right? But if you look at these other graphs, these other rectangles, they're actually an underestimate, because you can see this yellow area here on both of these graphs, on both of these rectangles. This yellow area is not accounted for because it's an underestimate, right? So in this case, we actually have 1 overestimate and 2 underestimates, so they're kind of equaling each other out, but in any event, you have an estimate of the area here. So let's do this again, and this time we're going to divide it into more than 3 parts. We're going to divide it into 6. So in this case, our delta x is going to be 2 minus negative 1 over 6, and that equals 3 over 6, or 1/2. So our interval this time is going to be 0.5 or 1/2. So in other words, instead of having a rectangle that goes from negative 1 to 0, we're going to have one from negative 1 to negative 0.5, one from negative 0.5 to 0, etc. So let's see what this comes out to. And remember, our estimate, let's write this down up here. Our estimate when n equals 3, our area estimate was So what was our area estimate for n equals 3? Our estimate was 8. So let's see what we get this time. So we're going to do the same thing. We're going to divide our area into a bunch of rectangles, 6 to be exact, and they're going to have a width of delta x of 0.5. So our first rectangle, the width is going to be from negative 1 to negative 0.5. Our height again is going to be the value of the graph at the left point. So this is our first rectangle. Now again, our delta x is 0.5, and we know from before our height is 3. Our second rectangle is going to be from 0.5 to 0. This value is going to be our height. So this is our rectangle here. And again, our width is 0.5. Now in this case, our height is going to be the function evaluated at negative 0.5. Well, we plug this in, negative 0.5. We square that, we get 0.25 plus 2. So this height is going to be 2.25. And we'll make another rectangle here. We're going to make it the width of 0.5 again. The height is going to be here. So this is our next rectangle. Now this width is 0.5. Our height here we know from before is 2. So this height is 2. Alright, do the same thing here. Width of 0.5. Our height starts here. So this is our next rectangle with a width of 0.5, and this height is the value 0.5 of function evaluated at 0.5, which is again 2.25. Two more rectangles left. So this one is going to be a width of 0.5, height here evaluated at 1. So this guy. Now this height is the function evaluated at 1, so it's 3. And then one final rectangle. We have a width of 0.5, function evaluated here for the height. So this guy here is our rectangle. So again, we have a 0.5. I'm sorry, I left out this width is 0.5. Now this height here is the function evaluated at 1.5. Well, what's 1.5 squared? We're going to put this in the formula here. 1.5 squared is 2.25. So this height is actually 4.25. Now it's just as easy as it was before. It's just going to be a little more math involved. So let's go back and put these together. So the area of this rectangle, 3 times 0.5, well that's just 1.5, plus the area of this rectangle, 2.25 times 0.5. Well, what is that? That is actually 1.125. And the area of the third rectangle is going to be a height of 2 and a width of 0.5, so that's just 1. Get the right color there. That's just 1. And the green triangle is the same area as this red triangle. It's still 2.25 times 0.5, so that is plus 1.125. Now our fuchsia here, the height is 3, width is 0.5, so that's 1.5. And then finally our orange here is 4.25 times 0.5, so that's going to be 2.125. So if we add all this together, we get, what do we get? we get the 1.5s, and the 1.5s equal 3. Add 1 to that, we get 4. We add 1, 2, 3, 4 to that, we get 8. And then we just have the 0.125s, so that will be 0.375. So for this, our area estimate is 8.375. Now, we're getting closer to the correct estimate. Our areas that we're leaving out or underestimating are getting smaller as we get more rectangles here. And actually, the more rectangles you get, you eliminate more and more and more and more of that, and actually the limit as you make n infinitely big becomes the actual area of the that you're looking for. That's a topic for another time, but hopefully you were able to use this video and learn a little bit about estimating areas under the curve.